Hi guys, and welcome back to section 0.4. Our second lesson is solving systems of two linear equations using elimination. Yesterday we used substitution. Today is just another algebraic method to find the solution to a system of equations. Your learning target is I can solve a system of two linear equations using elimination. First of all, let's talk about what elimination is. Elimination is an algebraic method used to solve a system of equations. The goal of elimination is to use addition of equations to eliminate a variable in order to solve for the remaining variable. If you remember when we used substitution, we technically eliminated a variable by doing that as well. But the method with elimination is adding the two equations together, not plugging part of one equation in for a variable in the other. When we use elimination, we use these 5 steps. Step number 1 is make sure both equations are in standard form. Now, standard form is ax plus by equals c. So we have both variable terms on the left and our constant term on the right of the equal sign. After we ensure that both equations are in standard form, we determine which variable we would like to eliminate. Now we try to make this as easy as possible. Since we are going to add these equations together, we want the terms to be opposites of each other. Opposites would be, for example, a negative y and a positive y. Those are opposites of one another. If I would add those together, I would get 0. You could also have negative 2x and a positive 2x. Again, adding those together, I would get 0. So if we look at our equations, and if the coefficients on a certain variable are opposites of one another, this variable would be a good choice. Well, that's just if it starts that way. Step 3 is if the coefficients of a variable you have chosen to eliminate are not opposites of one another, then we have to use multiplication to one or both equations to make them opposites. So that's a step we might have to do. Once we have ensured that we have two opposite coefficients on the same variable that we want to eliminate, we add the equations together and solve for the remaining variable. And just like with substitution, we write our answer as an ordered pair xy. All right, let's get started. Solve each system using elimination. Express each solution as an ordered pair xy. Looking at example A, I first am using step 1, I'm going to double check that these equations are in standard form. And as I can see, my first equation has 4x plus 5y equals negative 13. Then my second equation, negative 4x minus y equals 9. That's what we want. We want the x, then the y, and then the constant on the other side of the equal sign, so that if I would make this addition problem, it would be easy to combine like terms. Next, I need to decide what variable I want to eliminate. Now, this is the part where we ask ourselves, are there variables that already have opposite coefficients? And in this particular one, there are. If we look here, we have a positive 4x and a negative 4x. Those are opposites of one another. So I do not have to do any multiplication to change anything to ensure that they are opposites because they already are. So we are going to eliminate x. Eliminate x because the coefficients are already opposite. So what we do is we can just go ahead and make this a big addition problem. And negative 4x and positive 4x cancel out. 5y minus 1y is 4y. And then negative 13 plus 9 is a negative 4. Now we have a really simple equation to solve. We just divide by 4 on both sides, and we get y equals negative 1. Now, as we know, this is only half of our solution. So For the second half, we do need to use substitution. We can substitute this y into either of the equations. I'm going to substitute it in the first one, just because I don't have negative signs in the first one. I have 4x plus 5 times my negative 1 that I got for my y equals negative 13. So this is 4x minus 5 equals negative 13. Add 5 to both sides. 4x equals negative 8. And divide by 4. X equals negative 2. So my final answer is the point negative 2, negative 1. All right, that example had already opposite coefficients, so that was a pretty good one to use elimination on. Let's look at example B. Here in B, remember our first step, ensure that both equations are in standard form. So we want our x term first, then our y term, and then our constant on the other side of the equal sign. Our first equation is good. 5x minus 2y equals negative 2. Our second equation, however, is not in standard form. We just need to switch the x and the y. So I'm just going to rewrite the system. I'm going to rewrite the first one as is. And the second one, I'm just going to write it as 3x plus 4y equals negative 22. Okay, so I have my variables stacked on top of like terms. Now I check, are any of the coefficients on the variables opposites of one another? If I look to my x terms, I have 5x and 3x. Neither of those are opposites. Look to my y terms, I have negative 2 and a positive 4. Those also are not opposites of one another. However, they do have opposite signs, so that's one step in the right direction. And also, I could just multiply negative 2 times 2 to get a negative 4. So I think I'm going to eliminate y. That seems like a good choice. And how I do that is I have to take the entire first equation and multiply by 2. That means I distribute this 2 to every piece of the equation. And I'm just going to write that new one underneath this bottom one. So 2 times 5x is 10x. 2 times negative 2y is negative 4y. 2 times negative 2 is negative 4. And now we see we have opposites, which makes our addition what we want will happen, what we want to happen. Those will cancel out. So 3x plus 10x is 13x. 4y minus 4y cancels. Negative 22 and a negative 4 gives you negative 26. Finally, divide by 13. Negative 26 divided by 13 is negative 2. We decide which equation we want to use to plug this back into. I'm going to plug it into the top equation, 5x minus 2y equals negative 2. So 5 times negative 2 minus 2y equals negative 2. This is I'm plugging it in. That's negative 10 minus 2y equals negative 2. Add 10, add 10. Negative 2y equals 8. Divide by negative 2. And y equals negative 4. So my solution is x, negative 2, comma y, negative 4. And that is the point where these two lines intersect.